Or one, rational functions. Rational means what? Am I not sharing?
You are, but mine's all black.
Okay, sorry. Rational means what? First 5 letters of rational are ratio. What's a ratio? Fraction. Okay, so a rational function is going to be a polynomial divided by a polynomial. Not a big deal. We're going to talk about domains and domains of rational functions. We're going to talk about vertical and horizontal asymptotes and how to find them. And then we're going to do word problems. There you go. Let's just scroll down first. There we go. Scroll down. A rational function is a quotient of a polynomial and a polynomial. What can you not divide by? Can't divide by 0. Okay. So that means that if f of x is equal to n of x divided by d of x can't be 0, right? So you have to find values of x that make d of x 0, throw them out because they can't be part of the domain. And we'll talk about more of this later. Moving on. Here's a function that we worked with in the past, a very simple rational function. It's actually the most simple rational function I could think of. What is the domain of f of x equals 1 over x? Well, we start with our function. And if you remember, when we talked about domain in the past, I told you, if I give you a function, the first thing you want to do is assume that the domain is all real numbers, right? After we assume, okay, the domain is all real numbers, then we look at except, and we got to find those exceptions. Okay, in this case, we can't divide by 0, so x can't be 0. Y'all remember what the other problem we talked about is? Division, dividing by 0 is one problem we talked about with function. What was the other one?
Dividing by
Not dividing by.
Square, you can't square root of negative.
You can't take square root of a negative number, right? So we would start to, okay, here we go. Here's the polynomial. Or here's the function, whatever it is. You can't divide by 0. You can't take square root of a negative number. And that's what restricts your domain. So back to this problem. Find the domain. Y'all have already told me the domain. Fred did anyway. He said x can't be 0. Is that the domain? Yes. Okay. So the domain is x can't be 0 because if x was 0, then you'd have 1 divided by 0, which is impossible. We could also write that as negative infinity to 0 parenthesis union 0 to infinity, right? And that's saying the same thing. That's the domain. So that's part of this question. Question number 1 said to find the domain, and then it said discuss the behavior of f, discuss the behavior as that of that function near the excluded values. Okay, so let's think about this. We know that, let's put a 0 right here. We know that x can't be 0. I'm going to put in some numbers over here and some numbers over here. Okay, so here's some x values, and let's go with, like, I don't know, -3, -2, -1, 0, 1, 2, and 3. And let's see what's happening. So if I plugged a -3 into this function, I would have 1 over -3, which is -1/3. If I plug the negative, so what I'm doing here is I'm on the negative side of 0. I'm going to kind of walk, if you will, and get closer and closer to 0 and see what this function is doing. That's what it's asking for, right? Describe the behavior of f near the excluded x values. So plug in -2, what do I get? -1/2. Plug in -1, what do I get? -1. Let's do some more. What if I plugged in? Let's get closer to 0. Give me a number closer than -1. -1/2?
Yeah.
What happens if I plug in a -1/2? What do I get? 1 divided by negative 1/2. Negative 2. What if I give you another number even closer? Negative 1/4. If I plug in a negative 1/4, what do I get? Negative 4. What's happening? Is it decreasing? To what? It's going to negative infinity, right? So as this function is coming, getting closer and closer to 0, it's going down. And it's going down. Can it get to 0? No, because that's an asymptote. Okay? What happens when you plug in 0? You get an error. Plug in a 1. Well, let's start at 3. Plug in a 3, you get 1/3. Plug in, plug in a 2. Plug in a 1. What's happening? Okay, you have to read it backwards because what I'm asking you is what happens as we get close to the undefined number. So as I'm getting closer, what's happening? And it's going to what? Okay. So what is the behavior of the function near 0? Well, on the left side or on the negative side, I'm going to show you how this is written in just a moment. On the negative side, as it gets closer and closer to 0, it's approaching negative infinity. But on the positive side, as it gets closer and closer to 0, it's going to positive infinity. Okay, and here's how this is written. The behavior of f near x equals 0 is denoted as follows. The function approaches negative infinity as x approaches 0 from the left side. Does that make sense? That this negative sign doesn't mean from the negative side. It means from the low side. Okay? So when you see a negative raised like that, that means I'm approaching that particular 0 or that particular asymptote from the left. Because don't numbers get smaller that way? Right? The function approaches infinity as x approaches 0 from the right. Again, this does not mean we're dealing with positive numbers being plugged in. This means we're plugging in numbers bigger than the undefined space. Okay? Here's the graph, and we've seen this graph before. What do we call this graph in the past? It had a name. Not bad. The reciprocal function. Okay, this was the parent reciprocal function, right? Moving on. The graph has a horizontal asymptote, doesn't it? In the numerator, that 1, can 1 ever be 0? No. If I take that 1 and divide it into millions of pieces, do I still have something left? Yes. Okay. So the function approaches 0. It's not tracing again, that's fine. The function is approaching 0. This is a little bit on this side. Okay, we're down here right now. So as I go approaching infinity, negative infinity, the graph is getting closer and closer and closer to 0. On the other side, I'm approaching 0 as x approaches infinity. That's what this is saying here. So this graph has two asymptotes. It's got a horizontal asymptote on the x-axis. It's got a vertical asymptote on the y-axis.
So just because of 0,
What's that?
I just got 2, got 0, but it's got one on the edge and on the top.
It's just because of the features of this particular rational function. Okay, we're going to talk more in detail about horizontal asymptotes in just a moment. Okay, a line x equals a is a vertical asymptote of the graph when f of x is approaching infinity or f of x is approaching negative infinity. As x gets closer and closer and closer to that a value. This is all of the algebraic vocabulary involved with what's going on here. You might not quite understand it, and that's okay. We'll get to actual problems in a minute. Number 2 says the line y equals b is a horizontal asymptote of the graph when the function approaches that particular value of b as x goes to infinity or negative infinity. Here are 3 functions. This first function is 2x plus 1 over x plus 1. And this graph has a horizontal asymptote at 2, y equals 2. It has a vertical asymptote at x equals -1. We're going to talk a little bit about where those came from. Y'all can see the vertical asymptote easy, right? X plus 1 equals 0, so x equals -1 is the vertical asymptote. Can y'all see where the horizontal asymptote came from by chance? That's okay, we'll talk about it in a minute. Number 2, or part B here, I have 4 over x squared plus 1. Is it possible for the denominator to be 0? Can x squared plus 1 ever be 0? Why not? But is it possible for x squared plus 1 to be 0? How? Give me the value of x that'll make that 0. I'm waiting. It can't, right? You give me any number, I'm going to square it. It's going to be either positive or 0. Take any 0 or positive, I'm going to add 1 to it. Can it be 0? No. So this graph does not have a vertical asymptote. However, this graph does have a horizontal asymptote at x equals 0. Anybody have any idea why this one has an asymptote at 2 and this one has an asymptote at 0? Any thoughts? Huh? I'm just saying what the asymptotes are. Why are those horizontal asymptotes? Do you know? Can you see it?
Well, it looks like there's a translation. No, it's not.
Pardon?
On the first one, on part A.
That transformation going on, kind of looks like that. It does. Part C, I have 2 over x minus 1 squared. So obviously x can't be 1. So that gives us a vertical asymptote. This graph also has a horizontal asymptote at y equals 0. So those are just examples of what these asymptotes would look like. Back to the reciprocal function and the 2x plus 1 over x plus 1. They actually have a certain name. They're called hyperbolas. A hyperbola is a conic section. Y'all ever heard of conic sections? If I had a cone like this, and I had an identical cone like this, these codes are exactly the same, so they look different. It's your eyes. A hyperbola happens when I take a double cone like this and cut it straight down. If I cut it straight down, it would have this look. I would have a parabola looking thing on this side and another parabola thing looking over here. That's what it would look like if you cut a cone straight down like that. Okay. Real quick, there's multiple ways to cut a cone. And that's why they're called conic sections. I used to have a model of one, and I could actually show you a three-dimensional object here. So cutting it straight down like that gives me 2 parabola-looking things, but because they're symmetric, they're actually called hyperbola. Section, conic section. If I was to cut the cone like this, notice it only cuts one side, one part of the cone. It doesn't cut both cones, just one of them. The result would look, this is where a parabola comes from. So a parabola is also a conic section. What would you see if I cut a cone straight across? That's a perfectly straight line across the cone. Okay. Think about what the base of a cone looks like. Yeah, so a circle is a conic section. What if I cut it straight through it and went all the way through the cone at an angle? Would that be a circle? No, this is called an ellipse or an oval. Okay, so those are your four different conic sections. You got parabolas, hyperbolas, circles, and ellipse. Okay. All right, moving on. Here is a beautiful rational function. This is the general form of a rational function. I have a polynomial in the numerator. I have a polynomial in the denominator. N of x and d of x have no common factors, meaning I cannot factor something out of the top and something out of the bottom and they cancel. We'll talk about that later. Right now we're saying, okay, these polynomials are totally reduced and we're going to look for vertical and horizontal asymptotes at that time. You cannot look for vertical and horizontal asymptotes until it's been simplified. Okay? Number one says the graph has vertical asymptotes when the denominator is 0. Y'all know that. Y'all know how to find those. The next one, the graph of f has one or no horizontal asymptote determined by comparing the degree of n and d. So here's what we're about to do. We're going to talk about the degree of the numerator and the degree of the denominator. And that's going to tell us if there's a horizontal asymptote, and then we're going to look at the coefficients and it'll tell us where it is. Okay? How many vertical asymptotes can a rational function have? How many vertical asymptotes can we have? Any thoughts? We have a bunch. We could have a bunch. If the bottom factored, let's say the bottom factored into x plus 2 times x minus 5 times x plus 4. How many vertical asymptotes do I have so far? That's 3 vertical asymptotes. Okay. So let me ask this again. How many vertical asymptotes can a rational function have? It could have 0. We saw one a while ago. Could it have 1, 2, 3? Is there a limit? Okay. How many horizontal asymptotes can there be? 1 or that's it. That's it. 1 or none. Okay. Okay, the word piece. If n is less than m, the graph has the line y equals 0 as a horizontal asymptote. If n equals m, the horizontal asymptote is determined by the leading coefficients. If n is greater than m, then there is no horizontal asymptote. What's that even mean? Okay, let's look at a few examples. Let me give you an example of part A. Part A says that n is less than m. Okay. So f of x equals 3x to the 4th minus 2x plus 1 divided by, I'm just making something up, 4x to the 6th minus 8. Okay. Looking at the numerator, which piece of the numerator is the most powerful, has the most influence in the numerator? 3x to the 4th has the most power. Why? Because it's got the largest power, right? It has the highest degree. Which part of the denominator has the most power? Okay, so if I was looking for this, and I right now, all I want to know is, do I have any horizontal asymptotes? All I care about are the 3x to the 4th and the 4x to the 6th. Okay, can y'all reduce that? Or does anything cancel? What? Can a few of the x's go away? So this simplifies to 3 over 4x squared. Does that make sense? Think about the value of x real quick. If x gets increasingly large, x gets bigger and bigger and bigger and bigger and bigger. Y'all with me? 3 divided by 10 trillion. That's a big number. 3 divided by 10 trillion. What's that answer going to be? Really small, getting close to what? Imagine that. Okay. So if the numerator, I'm sorry, if the power of the denominator is larger than the power of the numerator, like in this case, this one will have a horizontal asymptote at y equals 0. And that's what part A is telling us. I've got something, I don't know what it is, but I'm dividing by a huge number that's getting close to 0. Or I've got something, I'm dividing by a huge negative number, but it's still going to get closer and closer and closer to 0.
And then, so like, if it's able to reduce a nice fraction, what does that mean?
I don't care about the fraction right now. All I really care about is the power of the x's. Okay. Part B. Let me make up another function. G of x equals, it says when m equals m. Okay, so 2x cubed plus 6x squared minus 7 divided by 5x cubed plus 6x minus 4. Again, all I care about is the term that has the most power in the numerator and the denominator. 2x cubed over 5x cubed. Can you reduce that? What happens to the x's? They cancel, right? So if x gets to 10 million, do I still have 2 bits? If x goes to negative 10 million, do I still have 2 bits? I don't care how big x cubed gets, they're going to essentially cancel each other out, leaving me with 2 bits, which means I have a horizontal asymptote at y equals 2 bits. So what do we look at here? I looked at part A, the degree of the denominator is bigger. Part B, the degrees are the same. What's left?
N is greater than
Yeah.
Which means
the top number is bigger than the bottom.
the top is bigger, okay? So 6x to the 5th minus 5 over 7x to the 4th plus 2x. I don't know, I'm just making stuff up. Again, all I care about is the most powerful piece. The top powerful piece is powerful in the bottom. 6x over 7. What happens to this 6x over 7 if x is extremely large? So I'm dividing an extremely large number by 7. What's going to be the result of an extremely large number divided by 7? It's still extremely large, right? 10 trillion divided by 7 is still a lot, right? Negative 100 trillion divided by 7, that's still a lot, right? Is it getting closer to any particular number? It's either going to positive infinity or negative infinity. When this happens, no horizontal asymptote. If the degree in the bottom is bigger, if the degree in the top is bigger, no horizontal asymptote. Folks, that's the only 3 things that can happen. Nothing else can happen. Okay?
So So like whenever we do the homework, really all we have to do is look at the two biggest degrees of fraction.
Only when you're looking for the horizontal asymptotes. Yes.
Oh,
If you're looking for the vertical asymptotes, I want the whole bottom set to 0. If I'm wanting to graph it, I've got to pay attention to my original function. Other questions?
this is pretty easy. For like that specific part, for horizontal asymptotes, just not easy.
Letter A.
Yeah, very.
The directions for these problems say find all vertical and horizontal asymptotes of the graph of each function. All right, letter A. Let's do horizontal asymptotes first.
Well, good.
2x over 3x squared.
Okay, we have 2x over 3x squared, which leads to
2 over 3x.
2. That's a nice 2. 2 over 3x. Okay, so what's happening? Getting closer to 0 because the bottom's getting big, right? So does this have a horizontal asymptote? Yes. Where's it at?
0.
Because this number is approaching 0. Okay, let's talk about vertical asymptotes. How do you find vertical asymptotes? 3x squared plus 1 cannot be 0. Okay, I want to talk about this real quick. What I'm doing here is I'm finding out the domain. I'm finding out what x can't be. If I find a value that x can't be, that means that that value of x is, for now, an asymptote. Okay, it could be something else later on, but right now we're talking about our asymptotes. Okay, so can you make this thing 0? Because we would have what? 3x squared equals, can equal -1. Well, I can't square anything and get a negative number, right? So do we have any vertical asymptotes? Okay, so in this particular problem, 3x squared plus 1 can never be 0. It's not going to happen. There is no vertical asymptote. Okay. And that's it for part A. Part B. Let's start by looking for horizontal asymptotes.
You get 2x squared over x squared.
2x squared over x squared, which gives us 2. Do we have a horizontal asymptote? Okay, remember, this is going to 0. This is 2. It's not going anywhere. It's 2. Horizontal asymptote?
No.
Yes. Horizontal asymptote at y equals 2. Vertical asymptotes. What do we do? Okay. X squared minus 1 can be 0. Does this factor? Factors into, okay. Which means x can't be -1, x can't be. Okay. So this is, again, this is talking about the domain. For the domain, x can't be 1, x can't be -1. So what happens at x equals 1 and x equals -1? I have a vertical asymptote at x equals -1 and at x equals 1. That is the location of my 2 vertical asymptotes. Questions or thoughts on these?
Horizontal seems really easy.
Horizontal asymptotes are easy because there's only 3 things to look for.
Yeah.
Vertical
Vertical.
asymptotes involve your favorite F word in math,
Factoring.
which is factoring. Okay.
Okay, calm down.
Okay. Here's what the first graph looks like. That's what the graph of 2x minus 3x squared plus 1 looks like. I want to point something out here. There's a horizontal asymptote, isn't there? The horizontal asymptote is at 0, which is the x-axis. But I want you to notice the graph actually crossed an asymptote. Okay, so what happens is over here, it's just going to get closer and closer and closer to 0 from the downside. And then it goes through the asymptote and then it approaches. So horizontal, and later we'll talk about slant asymptotes. Horizontal and slant asymptotes can be crossed. But if you're talking about as x approaches negative infinity or x approaches positive infinity, in the end, the graph will get closer and closer and closer to that asymptote without touching it. But somewhere in the middle, it is possible to pass through it. And that's okay. So there's that graph. Let's look at the graph of the other function. We said there were 2 vertical asymptotes and 1 horizontal, right? I guess we'll talk about it in a second. This is part B still. This is part B, finding the y equals 2 is the horizontal asymptote. And then factoring it, we get -1 and +1 as our zeros, and there's the graph of it. So we have a horizontal asymptote at 2. We have a vertical asymptote at -1 and +1. Can a graph cross a vertical asymptote? Can a graph cross a vertical asymptote?
No.
No, because x doesn't exist for the function at that point, so it can't. But it can cross horizontal, it can cross slant. We'll talk about this later. Word problem, your favorite. A utility company burns coal to generate electricity. The cost, C in dollars, of removing P% of the smokestack pollutants is given by this function. So to make the air clean is going to cost the company money, right? As to make electricity. Here's the function. I think if you look at the one online, it's correct. This one's wrong. It says that P has to be between 0 and 100. Look at the function. Can P be 100? No. So this is wrong. This should be gone. Can P be 0? Can we burn and eliminate no pollutants? Yes. Can we have negative pollutants? No. Okay, so this should be 0 is less than or equal to P less than 0. It says to sketch a graph of the function. We'll worry about that in a little bit. You are a member of a state legislature considering a law that would require utility companies to remove 90% of the pollutants from the smokestack emissions. Current law requires 85%. How much additional cost would the utility company incur as a result of the law? So currently they remove 85% of the pollutants, but the new law passes, nope, you got to move that up to 90% gone. That's going to cost the company more money, right? Okay. Can y'all answer that part of the question without graphing it?
No.
Some people can, some people can't. How would you find out how much it costs to remove 85% of the pollutants? Yeah, that's just saying P is 85, right? So if you plug an 85 in there and an 85 in there, you can get me a cost. So what is the cost of removing 85% of the pollutants? And I don't know if it's equal or approximate, so I'm just gonna do that. Okay. So this company is going to be paying close to $500,000 to remove 85% of the pollutants. That's a lot of money, right? But now the law says, hold on, 85 is not good. It's now 90. I'm gonna just make a guess at it. Just gotta remember it from earlier. That 5% is gonna cost the company $270,000 more. Is the company gonna pay $270,000 more to remove that much of the pollutants?
They're gonna find a way to cheat
What are they
it
gonna
out.
do?
Find a way to cheat it out.
No, they're gonna charge you more for your electricity. That's what they're gonna do.
I wonder if Volkswagen did it one time.
Okay, but that's what's happening. So this is what's going on here. So let's think about this graph for a second. I only drew quadrant one. Does it make sense to just draw quadrant one? Can we have negative pollutants? Can we have negative costs? Okay, so how much would it cost to remove nothing? Nothing. So if this right here represents 100, that's an asymptote, isn't it? What is going to happen to the costs incurred by this company as the percentage of pollutants is removed? It's going up. Does it go up fast? Always goes up fast, like a straight line?
No, can be exponential.
Is it possible to move 100%? No. How much would it cost to remove 99.9%? Don't even go there. Okay? Because you will see this is what the graph's doing. Okay. So I have sketched a graph. I didn't label it. You should always label your graphs. But you don't have to label as much as they do. I think that's a little overkill. Drawing pictures and stuff in there. Got your factory and all this. So there's a sketch of the graph, just like I drew.
I think yours is better.
Mine's is better.
Yeah.
I appreciate that.
I do.
Here's the map.
Do you want to draw pictures of yours? Why not?
I'm not drawing pictures.
No.
There's a reason I teach math and not art.
Well, pictures are cool.
Okay? Here's the answer that we got a while ago. Like I said, about $270,000 more just to make the government happy, but they're gonna pass those costs on to their customers.
I mean, that's such an all they are removing pollutants from the air.
Okay,
And then people just aren't gonna buy them.
and folks, that is, that's the end of 4.1. So, Bells, you got a couple minutes?
I'm not gonna be here tomorrow.
Okay.
Wait, why? Oh, we're even see everything.
Like,
Mm,